Myself, Sheikh Ansar BASHA. I am from Department of Electronics and Communication Engineering, 𝑃Tech Multitech, Dr. Rangarajan Sakunthala Engineering College. And our teammates are Gaddam Bharat, Survamsi Kumar Reddy. And our project title is Object Detection, Localization and Tracking using Single Shot Detector. Our project was guided by Mr. G. Vishnuvardhan Rao Sir, M.TECH, Assistant Professor, ECE. Our project abstract is we are trying to detect, localize and classify objects in an image using neural networks. We are using single shot detector for performing the task. The output of single shot detector is bounding boxes. It will try to localize the objects in an image and also tell which object is present in an image. The network predict probability scores of all classes. We will take the highest probability of all the predicted probability of all the classes. The objective of our project is this will classify 90 objects and it will track them in a real world scenarios. Our objective is to identify things using single shot detector, and also it provides classification along with tracking. This object can be used in security purpose, fast track, etc. The existing system is save time labeling polygons for instance segmentation by drawing a simple rectangle that resolves to an object. Tracking a labeled objects from frame to automatically apply polygons or bounding boxes. Select common objects to recognize and plain sight will use pre-trained models to automatically apply labels. Literature survey is that detects the qualified level in a video frame. Deep learning models were deployed using CNN and RNN. Using the same encoder, a design that blends the two technologies was created. The proposed methodology outperformed the most competitive methods currently available on 6 real-world datasets according to the experimental analysis. Lot of people investigated and compared the accuracy of several CNN designs. They were able to examine video data from cameras in real world and spot suspicious activities because of their system architecture. They also made suggestions for further developments in this field. Presented a TSC that can be recorded to a SRNN, allowing for parameter optimization and faster dubious prediction. For discovering abnormal activity, create a massive dataset that is even greater than the total of all current datasets. The algorithm works on a principled convex optimization formulation that allows both a sparse reconstruction code and an online dictionary to be mutually inferred and modernized based on the perception that common events in a video are most likely to be constructible from an event dictionary, whereas infrequent events are not. So choose implementation part. We are using single shot detector with high speed and performance used for multi-class classification. This algorithm is better than all the algorithms of previous proposals. In SSD, we are not using region-based proposals. This single shot detector predicts bounding boxes and classes using specific feature maps, which is exploited from neural network. We are using COCO dataset to train our model and network graph architecture. The block diagram is this is the architecture of SSD, in which we are passing an input image through the sequence of convolutional layers, and the output is predicted from the probabilities. On the video detection, there will be one or more bounding boxes. The best bounding boxes will be filtered by putting a threshold. It is combination of both object classification and object localization. In an input image, both bounding boxes and predicted class labels will be put together in a single input image. The hyperparameters for the SSD model is we are training an epochs of 1,76,000 and using a batch size between 6 and 10 images, and we are using an optimizer of RMS propagation, and the learning rate is 0.01 to 0.04, and we are using momentum of 0.9 and a decay rate of 0.9. The advantage of our SSD model is to identify and locate one or more effective targets from still image or video data, traffic management and sports training, video surveillance system, image segmentation, image captioning, object tracking. And the few applications of our SSD model is It is used in many applications like recognition of things in home. It is used in IoT based applications. It is used in automobile and self-driving cars. It is also used in security systems. The conclusion is this paper tells about single shot detector. The key task is our model SSD is to use different sizes of convolutional blocks with different stride and padding values to increase performance of network. The priority boxes increases the large accuracies of bounding boxes without learning from scratch. We have built the SSD model with a large number of bounding boxes for different scales of images with different aspect ratios. SSD model is used in real-time object detection which gives high speed and accuracy. And the references part is here are our references. Coming to the coding part, we are using Python and these are all the libraries we are using in our project. Coming to the model part, we have trained the SSD model and we are loading the SSD model here. Load frozen TensorFlow model into library. This will load the SSD model graph into the local server. Here is the detection. We are creating a function run inference for single image. This will detect the detections in an image. And this is used for writing the text. We are using the declared above functions to detect the image, and we are using the image to detect. By running detections on image, we have got these predictions. The first image is car with an accuracy of 85%, and the second image is motorcycle with an accuracy of 97%, and the third image is motorcycle, and the fourth image is car. And this is the code for detection on video. This will take an input video and it will use SSD model to draw output bounding boxes, and this will be saved into the same directory with an file name output.mp4. This is the input video which we are giving to the SSD model. This video is the output from the SSD model, and it will draw the bounding boxes of the things which it will find in a video. The above part is it will classify whether it is a person or a car or a bike, and it will give the corresponding accuracy. This is all about our project. Thank you.